Picture this, a fire, 100,000 years ago. You're cold, you're hungry. Something massive is lurking just outside the light. You want to warn your buddy across the fire. So you do what any modern human would do. You open your mouth, and absolutely nothing comes out. Because here's what nobody talks about. There was a real, documented, scientifically verified time when human beings could not speak. Not a single word, not a grunt that meant anything. Just biological silence. And the question of how we went from a creature staring blankly at a mammoth to a species that invented podcast drama, political debates, and I'm fine when we are clearly not fine. That question is one of the most insane mysteries in all of science. And we're going through it today. Let's start with the problem. Unlike bones, unlike tools, unlike cave paintings, language leaves no physical trace. You cannot dig up a fossil and find a sentence. You cannot carbon date a conversation. Language is made of air, and air does not preserve well over geological timescales. So scientists studying the origin of speech are essentially forensic linguists, piecing together an ancient puzzle from skull shapes, hyoid bones, genetic mutations, and cave art, and a lot of educated guessing. Before we go further, we need to get something straight. What exactly is language? Because before humans had real language, we almost certainly had something. Animals communicate. That's not up for debate. Bees do a waggle dance to tell their friends where the good flowers are. Dolphins have signature whistles that function like names. Chimpanzees in the wild have calls and gestures that convey basic information. So the question isn't, when did living things start communicating? The question is, when did communication become language? When did it cross the line from signal to symbol? Because there is a massive, fundamental difference between the two. A signal is direct. It means one thing. A dog growls because it's threatened. The growl is the threat. But a symbol is abstract. The word danger is just an arrangement of sounds. It doesn't look like danger. We all just agreed that those vibrations in the air would mean that specific thing. Think about how insane that is. Every word you've ever spoken is a social hallucination that billions of people happen to share. And making that leap from signal to symbol, from direct response to abstract meaning, that was the cognitive revolution that changed everything. Now, scientists don't agree on when it happened. And that's honestly part of what makes this so fascinating. There are two major camps. They've been fighting about this for decades. Camp 1 says language evolved gradually over hundreds of thousands of years, slowly complexifying from simple calls into full grammar. This is the continuity hypothesis. Its supporters point to chimps, bonobos, gorillas, who already show rudimentary symbolic thinking. They can learn signs. They can combine symbols in new ways. They seem to understand that things have names. Maybe language is just the end point of a very long road. Camp 2 says something completely different. They say there was a moment, a specific leap, probably somewhere between 100,000 and 50,000 years ago. Some mutation, some threshold of brain complexity that suddenly unlocked full recursive syntax, the ability to embed ideas inside other ideas. The man who I think knows the woman who lost the dog, sentences inside sentences, and before that moment, nothing even close. This is the discontinuity hypothesis, and if it's right, language didn't grow, it erupted. The truth is probably somewhere in between, and it involves several different pieces coming together at different times. Let's talk about the body first, because language isn't just a mental thing, it's a physical one. To produce the sounds that make up human speech, you need very specific anatomy. And for most of evolutionary history, our ancestors didn't have it. The key structure is the larynx, your voice box, and more specifically, its position in the throat. In most mammals, including our closest relatives, chimpanzees, the larynx sits high in the throat. This is actually useful for them. They can breathe and swallow at the same time. Less risk of choking, practical, efficient, but it severely limits the range of sounds they can produce. In humans, the larynx sits much lower. This creates a larger, resonating chamber, the pharynx, which is what allows us to produce the full range of vowels and consonants that make speech possible. The trade-off? We can choke. We are literally the only mammals that regularly die from inhaling food. Every year, thousands of Americans choke to death on things like poorly chewed steak or ambitious sandwiches. Evolution looked at the ability to speak and said, yes, worth the risk of dying to a rogue piece of bread. Now, larynx position doesn't preserve in fossils. Soft tissue doesn't fossilize, so we're back to inference. But here's what does preserve: bone. And there's one bone in particular that gives us clues: the hyoid. The hyoid is a small U-shaped bone in your throat. It anchors the muscles used in speaking and swallowing. It's the only bone in the human body that doesn't connect to any other bone. It just floats in there, held by muscles and tendons. In 1989, a complete hyoid was found at a Neanderthal burial site in Israel Kabara Cave, 60,000 years old. When scientists analyzed its shape, they found something remarkable. It was nearly identical to a modern human hyoid. This was a massive deal. It suggested that Neanderthals, our thick-browed, stocky cousins who lived across Europe and Asia, might have had the physical capacity for speech. And then the genetics people showed up, and things got really interesting. In 2002, scientists identified a gene called FOXP2. It immediately became famous, probably too famous. The press started calling it the language gene, which is a massive oversimplification that made every actual geneticist quietly scream, but the reason it got that nickname is real. Humans with damaged copies of FOXP2 have severe difficulties with speech and language. They struggle to coordinate the fine motor movements needed for speaking. They have trouble with grammar. It's genuinely debilitating. What made the discovery explosive was this. The human version of FOXP2 is different from every other mammal's version, including chimpanzees. Mice have FOXP2. Songbirds have FOXP2. Even crocodiles have FOXP2. But the human variant has two specific mutations that don't appear anywhere else in the animal kingdom. Mutations that evolution really wanted us to have. And then researchers tested Neanderthal DNA. They had extracted it from ancient bones. And when they looked at the FOXP2 gene, the Neanderthals had the same human mutations. The same ones. Which means Neanderthals and modern humans shared this genetic adaptation for speech. And since both lineages diverged from a common ancestor at least 400,000 years ago, FOXP2 had to have been present in that common ancestor too. So here's where that leaves us. By at least 400,000 years ago, possibly earlier, our ancestors had the genetics for the physical coordination needed for speech.